All right, so this is video 1B. So we're still solving equations, but with a variable on both sides. The goal is still to isolate the variable or to move all of the variables to one side and all numeric values to the other side. Remember a couple things here. Order matters, so the order that you do the process definitely matters. Again, think of order of operations and go backwards. So start with your addition and subtraction step, moving backwards in the order of operations. And what you do to one side, you must also do to the other side. All right, so our first example says x plus 4 equals 2x minus 3. So I'm going to do this problem actually in two different ways, okay? Because the joy about multi-step problems like this, you can do them in a different order and still get the same answer. So we're going to put our bar down here. Again, the goal is to isolate the variable. So now we have a variable on both sides. Well, I always like to have my x value be positive. That is something that I've done for years. So to do that, I have a 2 on the right side and I have a 1x on the left side. So I'm going to subtract x from both sides. I chose to get my x's out of the way first. You could have done different. So I would have 4 is equal to 2x minus x is x minus 3 because that is a 1x there. And then now, of course, you're back to those type of problems that you've seen. You're going to add 3 to both sides, and you end up with x over here and a 7 over there. Okay? Fine, no problem. Now let's work through the problem a different way, because let's say that was not your choice. Let's say you've been taught always have the variable on the left side and the number on the right side. That's fine. Just gives you an extra step. So then my first step would be to subtract 2x from both sides. Remember, there's an imaginary 1 there. It's not saying that it is 1. It is saying there's an imaginary 1 sitting to the left of it, the most confused item. So 1x minus 2x is a negative x, or negative 1x. So you still have the plus 4 is equal to negative 3. So now my next step is to subtract 4 from both sides, because again, I want to get rid of that. I now have negative x is equal to negative 7. I never want a negative variable. Now remember, as you guys have been taught, there's a negative 1x there. So I can divide both sides by a negative 1. When I do so, I get my final answer of x equals 7. So again, it didn't matter which direction and which order I did them in. This one took me an additional step, whereas the other one didn't. Your choice, multiple ways of getting to the same answer. All right, so now from now on, I'm not going to do every problem multiple times. I'm just going to go through what I think is the best strategy for a problem. So I see a 4x, I see a 3x. I want that x to be positive. So I'm going to subtract 3x from both sides because I want it to be a positive deal. So 4x minus 3x is simply 1x minus 5 is equal to 6. And yes, if you would like to still write that 1x, that is totally fine if that makes you more comfortable. And then again, I need to get the x all by itself. So I simply have to add 5 to both sides. And I am left with x is equal to 11. All right, I purposely put this one in there because of that division problem, or that fraction as you guys call it. Again, don't get scared by this, okay? When you see this, you need to think multiply. That's to get rid of this guy right here. That's all you need to worry about is, uh-oh, I see this. Let me do what's opposite of that, which is multiply to get rid of that 5. Okay, so I'm going to multiply both sides by that 5 over 1. No big deal that there's a variable on the right side. Again, the purpose of why I'm doing that is because that 5 is going to cancel with that 5. So I'm going to be left with 2x plus 16 because the 5s are gone. But I do need to remember to multiply on this side. And I'm going to get a 10x. No big deal. So again, when I'm working through this problem, I'm looking at, okay, I've got a 10x on the right side, a 2x on the left side. I would prefer to subtract 2x from both sides so that I can get rid of that and have a positive x value. So then over here, I have an 8x. Over here, I have a 16. Well, that's really pretty, because now I'm going to divide both sides by 8. When I do so, I get x equals 2. No big deal that the variable is sitting on the right side and the number is sitting on the left side. It still works. It's still the solving of this equation. All right, now we have 3 parentheses x plus 4 is equal to 2x plus 14. Purposely put this in because of the distribution property that needs to happen with this problem. So for starters, I'm going to distribute. I have 3x plus 12 is equal to 2x plus 14. Again, I'm looking at my x values and I say, well, let me draw this bar right here. I've got a 2x on one side, a 3x on the other side. I want it to be positive, so I am going to subtract 2x from both sides. When I do so, this is great. I have an x plus 12 is equal to 14. Now we're back to that first type of solving equations problem. We're going to subtract 12 from both sides, and I'm left with x is equal to 2.